Hello everyone and welcome back. I'm really excited. Today we're learning about geometry, which is one of my favorite topics in math. Geometry is just learning about different shapes and how their properties affect how they look and how they interact with other shapes. Really cool stuff. I really enjoy it. Of course, I say that about every topic. Now, my son was going to join me, but he had other plans. I'm a little disappointed because he needs to learn a love for math, because as you know, I love math. Now, let's go ahead and look at our learning target for today. This is Module 7, Lesson 4. Our learning target is I can compare and classify quadrilaterals. We're going to be talking more about this word, quadrilaterals. My notepad's upside down. Let me flip that. We're going to be learning more about this word, quadrilaterals. Compare means that we're going to be looking at different quadrilaterals and having them side by side and talking about them. Classify means that we're going to be able to put them into groups, how they're similar, how they're different. So let's look at this application problem first. I always love a good application problem. It says the third graders raised $437 in a fundraiser. The fourth graders raised $68 less than the third graders. How much money did the two grade levels raise all together? Go ahead and pause this video and give this problem a try. I'm going to go ahead and jump into my solution. Something that jumps out to me is that they tell us how much the third graders earned. We're going to use a T to represent the third graders, but they didn't tell us how much the fourth graders earned. I'm going to use an F to represent fourth graders. Instead, they told us that the fourth graders raised an amount that was less than what the third graders had. So whatever the third graders had, it was $68 less. So this is me just using an equation to write it out, my thinking. Let me show it with a tape diagram. This is how much the third graders earned, 400, and I wrote it wrong right there. Let me fix that. $437. We know that this amount right here is $68. And whatever this amount is that fills in the rest of this tape diagram, that's how much the fourth graders raised. Now we want to know the total amount. And so, oh man, I'm out of letters. I'm just going to pick a letter A for answer. The answer of how much money did they raise altogether, this should be capitalized, is equal to how much the third graders raised plus how much the fourth graders raised. Okay, so I'm using variables to help me. Now let's figure out how much the fourth graders raised. It's 437 minus 68. Looks like I'm going to have to make some exchanges here. So this will be a 2, and this will be 17. 17 minus 8 is going to give us 9. 2, I need to make another exchange. This will be 12 minus 6. And then 3 minus nothing is 3. So I know that the fourth graders earned 369. Oh my goodness, I wrote it twice. Liam, are you sad because you're not doing math with me? Come here, bud. Looks like he decided to join after all. Come here. So our answer, we're going to replace our variable. Hey. I'm sorry I did math without you. You want to help me? Yeah. Okay. Gotta help. Okay. Now, Liam, you see this T? Yeah. That T is the same as 437, so we're going to go ahead and add that. 437. See, he's happy now that we're doing math. I'm also going to add how much the F equals. You see the F right here? Right there. Yeah, it's right there. It says that the F is equal to 369. And so anywhere I see the F, I can replace it. So now let's change colors. I'm going to add these two numbers together. I changed colors just so it's easier to see. We only got so much space. What, did you want to do it? Yeah. Okay, do you know what 7 plus 9 is?
8.
close. It's 16. Yeah, good job. And then we write our exchange, and we're going to add 1 plus 3 plus 6. Well, those are going to make a 10. Did you know that? It's 10?
My turn.
Your turn? Okay, I'll let you draw a picture in just a second. Now, 1 plus 4 plus 3. It's going to be 8.
3.
So our total answer, or A, is going to be $806. And we'd want to write that out. Oh my goodness. $806.
Not 86.
I know. We would want to write this out and say third and fourth grade raised $806 all together. Thanks, Liam. Can you say bye?
Bye.
Okay, bye. You can play Mario Kart.
No.
See, he'd rather do more math than play Mario Kart. Now, here's what we're talking about today. Geometry. Here's some terms that we want to keep in mind. I'm going to switch tools. Now, these are terms. A polygon, the root word for poly means many, and a gon, I believe, is shape. So what we're talking about here for a polygon is a shape that has multiple sides, a closed shape made of lines. There's a lot of different polygons. A quadrilateral is a type of polygon that has 4 sides. That root word quad means 4. If you think of like your quadricep muscles, there are 4 muscles in your legs, on the top part of your leg. If you think about when you're going out four-wheeling, some people call those quads. It's just a root word that means 4. So a polygon with 4 sides. Parallel is like these 2 L's. Parallel means if you have 2 lines, if you continue drawing those lines forever, they would never, ever run into each other. They'll always just run next to each other. So we'll get rid of that. When we're talking about a set of parallel lines, we're talking about, if I say there's one set of parallel lines, I'm talking about this shape just has parallel lines that could run next to each other. That's it. One set of them. So there's 2 lines, they make a set. Just like you'd have a set of silverware, they're things that go together. So these are, means it goes together. A right angle, if I have like a sticky note, a right angle, there's a way to measure this that you're going to learn next year. But if you measure this, it equals 90 degrees. A circle has 360 degrees, so it's 1/4 of a circle is that measurement. And so when we have a corner of something like that, a piece of paper, that is 90 degrees, and that helps us know it is a right angle. Perpendicular is when we have 2 lines. I'm going to draw a picture for this one. 2 lines that run into each other, and they run into each other so that they create 90-degree angles. If you have a line like this and another line like this, those are not perpendicular. You want them to run into each other, and they like go right into each other, T-bone each other, so that we have 90 degrees, 90 degrees, 90 degrees, and 90 degrees. So that helps give our definition a little more meaning, intersecting lines at a right angle. Finally, the last one is equal sides. When we have equal sides, it means that they are the same length, okay? They're the same distance. So when I ask that if all of the sides are equal, that's what I'm talking about. They all have the same distance, okay? This page is a good one to look back on. You can pause the video here as you're doing your work, maybe tab back to it to see what these terms actually mean. So let's talk about some shapes. I've got a whole bunch of shapes here. Now, which of these shapes have 4 sides? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Looking at it, 4, 4, 4, 4, 4, 4, 4, and 4. All of these shapes have 4 sides. And so when I am classifying them or trying to identify them, I'm going to say, yes, all of these have 4 sides. I think I did this wrong. Let's move these to the front. So I could put all of these over here in this chart. And it looks like I have to reorganize them a little bit to get them on here. but they all have 4 sides. You can check each one of these and see, does G, which doesn't want to move right now, have 4 sides? 1, 2, 3, 4. Yes, so we're good. Every one of those shapes has 4 sides. Now we're looking for 2 sets of parallel lines. Now I'm going to go ahead and I didn't do this earlier, so let me just, oh, that didn't work. Move these forward. Into front. So I'm only looking for shapes that have 2 sets of parallel lines. The opposite sides have to be parallel. So this line right here and this line right here look like they are parallel. Same thing for these ones. So here's one set and here's another set. Let me grab a color really fast. These 2 lines, this one and this one, they would never run into each other. That's one set. And then in blue, this line and this line, they would never run into each other. So they are also parallel. So that's 2 sets of parallel lines. So H goes here. A does not. B, it looks like B has 2 sets of parallel lines. C, even though it's twisted, if I kept those lines going forever, they would never run into each other. What about I? That one's kind of hard to tell. Maybe I grab a little line tool. Let me see. I don't remember if it's going to let me do this. I had a tool once that would let me just make these lines that would go forever and ever. Okay, so if I draw a line on this, I draw a line on this, and then I continue that line in this direction forever. I continue this line forever. It's kind of hard to tell, but I don't think they're ever going to run into each other. So that really shows what I'm talking about when I mention parallel lines. If I kept that line going, I'm pretty sure this one matches. This one, it's kind of hard to tell, but I'm pretty sure these 2 lines right here look like if I continue drawing them, that they would eventually run into each other. It looks like they're getting a little more pointy. So if I kept that going for a long time, I feel like they're getting closer to each other. So I'm going to go ahead and say that that does not have 2 sets of parallel lines. That one's not going in. This one, no way. This one, again, I can tell these lines right here, if they kept going, they're going to run into each other eventually, probably somewhere up here. So we're going to go ahead and say no on that one. No on this one. Now this one does have one set of parallel lines. I just want to point that out. It doesn't have 2 sets though. This one looks like it would work. This one looks like it would work. And our friend G looks like it would work. So these shapes all have 2 sets of parallel lines. 4 right angles. Now, if they only have 1 right angle, then we don't care. And this one would be hard. We want to take a tool like these note cards and stick them into the corner. I could, I guess, draw a square on here. And then we could use this square. And we could say, let's see, is this a right angle right here? And I can twist it. And I can put it in here. And I can check. That one looks like it's a right angle. But it doesn't have 4 right angles. So looking for shapes that have 4 right angles. Oh, see, I didn't do it again. Let's go ahead and pick all these. We're going to move them to the front. This one has 4 right angles. This one does. Even though it's twisted, this one does. This one does not. Those ones are not right angles. That one definitely not. Those are way too small. This one, no. This one doesn't either. That one's too small. That one's too big. Same thing here, here. This one looks like it does. This one doesn't. Those are too small and those are too big. So there was only 4 triangles that had 4 right angles on this one. And they're all rectangles or squares. That might come into play later. The last one I realize is repetitive. It's the same question as the very first one. Let's go back to that first one. It said, which shapes have 4 sides? And this last question over here is asking, which ones are quadrilaterals? Quadrilateral means it has 4 sides. So in other words, every single one of these, they want to go behind again. All of these are quadrilaterals. So we'll take it, we'll move them back to the front. And we're just gonna, boop, all of them go over there. You can't see G, but it's in this group as well. So as you're doing the problem set today, you're just classifying these ones. It's really important that you know those terms. We'll go back to the terms. In order to compare and classify the quadrilaterals, we need to know what these terms are talking about. Parallel lines and right angles are big. Perpendicular, that's a term that we might come into later. So I just wanted to share that with you. Equal sides is going to come up. If all the sides are the same distance, let's find a shape that matches that. It looks like F. Every single side is the same length. Same thing with I. All the sides are the same length. So keep these terms in mind. Good luck on your problem set. I am excited to be doing more geometry. This is just the start of it. I will see you guys